Okay, so we're going to do a word problem that has to do with athletes here. It says the product of the numbers of two consecutive entrants in a marathon race is 156. Find the numbers. Okay, the product is multiplying. So the product of two consecutive entrants. Okay, consecutive, they give you numbers when you enter, right? Consecutive entrants. Okay, it says the product of their numbers is 156. So you know you're going to multiply a number and the next number, and you will get 156 is what it said the product of them was. If you use x for one of the numbers, so we're going to use x, and you multiply it by the next number, what's the next number going to be? One more, right? The next number will be that number plus 1, x plus 1. So we have, when we multiply x times x plus 1, we have x squared plus x times 1 is x equals 156, but we want it to equal 0, so let's go ahead and subtract our 156. Minus 156 equals 0. We're kind of skipping a step there. Did everybody follow that? Okay. Now we need to factor it. And we want two numbers that will subtract to give us a 1. We know they're going to be one number apart. 12 and 13? Okay. We have the work done for us. That's good. Okay, if we need a positive 1, which one's going to be positive?
13.
13 is positive, 12 is negative. Set them equal to 0. This one will solve into 12. This one will solve into negative 13, right? Which one's going to be a number they're going to give a person that enters a race? They aren't going to give you a negative 13 for a number, right? So the first person is going to be a 12. So the next person will be 13. So their numbers are 12 and 13. If the 13 had been positive, it would be 13 and 14.
Because they're the consecutive.
Because they're consecutive, right? Okay. It's in the book also. It's the example in the book, so you can follow it in the book also. Okay, the Pythagorean theory. Have y'all seen that? Okay. These, in a right triangle, these two are your legs. The two sides that make up the right angle are your legs. The side that's opposite or across from the right angle is your hypotenuse. Okay? Okay, Pythagoras, this Greek man way back a long time ago, he played with a lot of right triangles, and he came up with this, what they call the Pythagorean theorem. He came up with this way to figure out how long this hypotenuse would be. Okay, if you have a triangle, I'm turning it around here. Say you had sides 3 and 4, you could find out how long this one is. And
Didn't we do that like for the
we probably have seen it before. That's why I was wondering if we'd seen this using A, B, and C. Yeah, A squared plus the B squared equals C squared. You remember that now?
Yeah, to get the 180.
Right, not to get 180. 180 would be your angles in here. The angles in here always add up to 180. And the Pythagorean theory is to find the lengths of the sides. So let's just go over it real quick again. If you had a 3 and a 4, This side here that you don't know would be your hypotenuse, so it's the one that's by itself. The hypotenuse is always by itself. So you'd have 3 squared plus 4 squared. 3 squared plus 4 squared equals x squared. Okay, so 3 squared is 9. 4 squared, 16 is equal to x squared. 9 plus 16 is 25. Square root of 25, or what times itself? No, what times itself is 25. The square root of 25 would be 5. So if this was 3 and 4, would equal to 5. And that works for multiples. If you had multiplied them by 2, 6, 8, 10 would also work. Times 3, then 9, 12, 15 is also a right triangle. Okay, and the reason it said that again is because we're going to need to use it for another problem now. Okay, it says there's a outdoor education ropes course includes a 25-foot cable that slopes downward from a height of 37 feet. So we need to start drawing this. We've got a cable that slopes. It said the 25-foot cable, so it's 25 foot long, the cable. It slopes downward from a height of 37 feet. So we put 37 as the height. It slopes downward from 37 feet to right here is 30 feet. So actually, if from here to the floor is 37, this would only be 7 feet, wouldn't it? This is a height of 37, and it goes down to a height of 30. So here's 30 feet here. So we only have a 7 foot right here. How far is it between the trees that connect the cables? So you're wanting to know how far it is from here to here, the part we don't know here. So making a smaller triangle, we have 7 distance between trees and our 25-foot cable. So we need to apply our Pythagorean theory. The 25 is our hypotenuse, it stays by itself. So here's our legs, x squared plus 7 squared equals 25 squared. So we have x squared plus 7 times 7, 49. And 25 times 25? 625. Okay, so what we need to do with this is subtract our 49 to get x by itself. So 625 minus 49.
576.
5 what? 576. X squared is 576. So what's the square root of 576? What times itself is 576?
288.
No,
24.
24. Put the square root of 576 is 24. So it's 24. These were caught using feet, so it's 24 feet between the trees. It's wanting a distance between the trees. And one more word problem, and it's another triangle. We have a picture of a ladder against a building. There's a ladder here. There's our ladder. It says that the ladder is 13 feet and it's placed against the building in such a way that the distance from the top of the ladder